So here we have our final question for our practice here, number 10. Differentiate between these two numbers. We have atomic mass and we have mass number. This was our focus today. So all of the information you need is right up at the top. Okay, and we've been working with this the entire day, focusing on how to use it to calculate protons, neutrons, and electrons, and to get some information on the isotope. I'll help you out with this one since this was our very first notes from 1026. We know that this information is found on the periodic table. Right? When we look at the element square on the periodic table, this is the decimal. And it's a decimal because it represents the average of all isotopes of that element. So if we're just thinking about this most recent one here that we looked at, manganese, maybe there's 15 different versions of manganese, lots of different isotopes. If we add all their masses up, divide by 15, we're going to get this crazy decimal that is not a very nice and neat number. So it represents the average of all isotopes. So it's calculated, just like we said, by adding all versions or flavors and then dividing up by the number. I'm not going to ask you to ever calculate the atomic mass because it's there for us on the periodic table. But I might ask you to calculate mass number because it's looking at a very specific calculation of subatomic particles in the atom. So use the notes up top to fill in your details about mass number.